On the 12th of August, a shadow moves across Iceland, clips Greenland, and races down onto the north of Spain. Inside that shadow, in the middle of the afternoon, the sky goes dark, the temperature drops, stars come out, and birds stop singing. It lasts around 2 minutes. For mainland Europe, it's the first total solar eclipse since 1999, which means most people standing in that shadow will be seeing one for the first time in their adult lives. And the thing worth understanding before it happens is that a total eclipse is not a normal astronomical event. It's a coincidence, a very precise one that didn't have to be true and won't stay true forever. Here's the coincidence. The sun is about 400 times wider than the moon. It's also about 400 times further away. Those two facts have no relationship to each other whatsoever. One is about the size of a star, the other is about the orbit of a rock that got knocked off the early Earth. They just happen to be almost the same ratio, which means that from where you're standing, the sun and the moon appear almost exactly the same size in the sky. That's what makes totality possible, and it's also what makes it beautiful rather than merely dark. The moon covers the sun's blinding disk so precisely that it leaves the corona visible around the edge. The sun's outer atmosphere, a pale halo streaming out into space that you cannot see at any other time. If the moon was slightly bigger in the sky, it would blot the corona out too. Slightly smaller and the glare would drown it. We happen to live at the one moment on the one planet where the fit is close enough to work. So why isn't there an eclipse every single month? The moon goes round us every 29.5 days, and once per lap it passes between us and the sun, which sounds like it should produce a monthly blackout. It doesn't, because the moon's orbit is tilted, only by about 5 degrees, which sounds trivial and isn't. That tilt means that on most passes, the moon slides above or below the sun from our point of view and misses entirely. The shadow still exists, it just goes over our heads or under our feet, off into space. Eclipses only happen in the narrow windows when the tilted orbit crosses the flat plane of our orbit around the sun at the same time as everything lines up. 5 degrees is the difference between an eclipse being a monthly nuisance and a once-in-a-lifetime event. Which brings up the strangest thing we know about eclipses. They repeat, and people worked this out an extraordinarily long time ago. There's a rhythm called the saros, about 18 years and 11 days long, after which the geometry of sun, earth and moon returns close enough to where it started that a very similar eclipse happens again. Babylonian astronomers identified this pattern from nothing but centuries of patient record keeping. They could not have told you what the moon was made of, or that the earth went round the sun. They could tell you when the sky was going to go out. There's a catch in the saros though, and it's a lovely one. 18 years and 11 days, plus about 8 hours. That leftover third of a day means the Earth has rotated an extra 120 degrees by the time the next one arrives, so the eclipse lands roughly a third of the way around the world from the last. Wait 3 cycles, about 54 years, and it comes back to roughly your longitude. The pattern was never really about the sky repeating, it was about the Earth turning underneath it. That predictability had consequences long before anyone understood it. There's an account from the ancient world of a battle between the Lydians and the Medes, somewhere around 585 BC, that stopped mid-fight when the day turned to night. Both armies took it as a verdict from somewhere above their pay grade, put down their weapons and negotiated a peace. The Greek writer Herodotus adds a detail that may or may not be true, that Thales of Miletus had predicted the year it would happen. A war ended because a rock passed in front of a star on a schedule. And it's worth knowing what totality actually does, because it gets dark, undersells it badly. The temperature falls, sometimes by several degrees, and you feel it on your skin. The light in the final minute goes strange and metallic in a way that photographs never capture, because it's sunlight from a shrinking sliver rather than a disk. In the last seconds, rippling bands of shadow can race across pale ground. Then the horizon lights up in every direction at once, a 360-degree sunset, because you're standing inside a shadow only 100 or so kilometers wide, and it's daylight all the way around you. Birds roost, crickets start. Animals that have no framework for this simply go to bed in the afternoon. Which is why eclipse chasing is a real and slightly obsessive hobby. with people who plan holidays years out around a line on a map and towns along the path that book out completely and make a year's takings in a weekend. The path this time runs through Iceland, Greenland and northern Spain, and northern Spain in August is where most people are heading because it's the stretch with the best odds of a clear sky and a road to get there on. And now the part that changes how the 12th of August feels. This is temporary. The moon is drifting away from us by a few centimeters a year, roughly the rate your fingernails grow. Tides are the cause. The moon pulls the oceans, the Earth's rotation drags that bulge slightly ahead, and the bulge tugs the moon forward, nudging it into a wider orbit while very slightly slowing our day. It's been happening since the moon formed. It hasn't stopped. A few centimeters a year is nothing on a human scale. On a geological one, it's decisive. The moon is receding, so it appears smaller in our sky, so eventually it will be too small to cover the sun completely. When that happens, totality ends. Permanently. There will still be eclipses. The moon will pass in front of the sun and leave a bright ring around the edge, an annular eclipse, but the corona will never be visible from the ground again. The last total eclipse in Earth's history has a date. It's hundreds of millions of years away, and it exists. Run it backwards and it's just as striking. In the age of the dinosaurs, the moon was closer, so it comfortably covered the sun, and then some. Eclipses would have been longer and cruder, with no delicate ring of corona. The precise fit we get is a window, and we are inside it, and nothing about that was arranged for our benefit. So if you're anywhere near the path, go. Not for the darkness. The darkness is only the setting. Go, because for 2 minutes, you can see the atmosphere of a star with your own eyes, from the surface of a planet, through a gap held open by a coincidence of ratios that no physics required and no future generation is guaranteed. And then it closes, and the birds start up again as if nothing happened. Which leaves a question worth carrying out of the shadow. How many of the things we think of as simply how the sky looks are actually just how the sky looks right now?